In this video, we'll generate the Bessel and the reverse Bessel polynomials using Taylor series expansion in Google Sheets and Excel. We'll use the we'll generate from 0 to 10, so 10 degrees. So data validation, that's the number of degrees where this is choose the range, so we have 10 degrees saved, and we have here we generate these polynomials to the 10th degree. The Bessel polynomial is y equals a times x to the power k, where k equals 0 to n, while the reverse is the summation of a times x to the power n minus k, where again k is from 0 to n. So this is equal to sequence the number of rows n plus 1, n plus 1, the number of columns 1, starting from 0, incremented by 1. So at n equals 0, our k value is 0, our n equals 1, k values are 0, 1, n equals 2, k values are 0, 1, 2, n equals 3, k values are 0, 1, 2, 3. Next, we continue with the coefficient, which is common to both the a value. So a equals array formula, starting with numerator. So factorial n plus k, n plus k. If this is empty, this should be 0. So we correct that. So if k is empty, so if k is empty, 0, otherwise calculate. Now it's corrected. So if k is empty, this is 0. We continue with the denominator, which has 3 parts. So the first part, factorial n minus k, n minus k. The second part, so times factorial k, so factorial k, that's the second part, times 2 to the power k, 2 to the power k. Enter. Now we continue. Now that we have the coefficient to be used by both Bessel and the reverse Bessel, we now enter the formula for the Bessel function. So it is the summation of a times x to the power k. So array formula, SERIESSUM of the x values to the power k. So raised to the power k, where k starts from 0, incremented by 1, and the coefficient a will be this range. Enter. And the reverse Bessel, which is equal to the summation of a times x to the power n minus k. So our formula, SERIESSUM of the x values raised to the power n minus k, where n minus k starts from n, incremented by negative k. So where k is incremented by 1, so minus 1. And the coefficient will be this range. Now we'll chart this. Insert chart, and we'll use scatter chart. So let's use scatter chart. We'll use scatter chart. Now that it's scatter chart, we generate using the series, the trend line, And we'll use polynomial so that all the points will fit in to the 10th degree because we use 10th degree, so 0 to 10. And we use the equation as label and relocate it at the bottom for easy comparison. So here you have the trend lines and the polynomials. In this case, you have to the third degree, so 1, 6, 15, 15, and the rest are 0. And here are 15, 15, 6, 1, and the rest are 0. We'll calculate these coefficients using LINEST. So these are the regression coefficients to calculate using LINEST. To do that, we complete the 1 comma x matrix. So this is equal to, this is our 1 comma x matrix, array formula of the x values raised to the power 0 to 10. Enter. So in this column, we have x to the 0 column. Here we have the x to the 1 column. That's why these values are the same. This is the x squared column because you square this will if this column is raised to the power 2 will result in this and so on. Now that we have the 1 comma x matrix, we can enter LINEST. So LINEST data y and data x. You avoid the x to the 0. Enter. So you have the coefficients 15, 15, 6, 1. And the LINEST for the reverse Bessel, data y, and data x. So our reverse Bessel will be 1, 6, 15, 15, which is the reverse of this part. Now we'll compare the coefficients starting from 0. At n equals 0, the Bessel and reverse Bessel both are equal to 1. At n equals 1, the Bessel and reverse Bessel are both equal to 1 plus x. 1 plus x. At n equals 2, the Bessel is 1 plus 3x plus 3x squared. 1 plus 3x plus 3x squared. While the reverse is 3 plus 3x plus x squared. At n equals 4 or 3, our Bessel is 1 plus 6x plus 15x squared plus 15x cubed. That's 1 plus 6x plus 15x squared plus 15x cubed. The reverse Bessel, 15 plus 15x plus 6x squared plus x cubed. That's 15 plus 15x plus 6x squared plus x cubed. At n equals 4, our Bessel is 1 plus 10x plus 45x squared plus 105x cubed plus 105x to the fourth. So 1 plus 10x plus 45x squared plus 105x cubed plus 105x to the fourth. The rest is 0. The reverse Bessel, 105 plus 105x plus 45x squared plus 10x cubed plus x to the fourth. 105 plus 105x plus 45x squared plus 10x cubed plus x to the fourth. The rest is 0. N equals 5. Our Bessel is 1 plus 15x plus 105x squared plus 420x cubed plus 945x to the fourth plus 945x to the fifth. That's 1 plus 15x plus 105x squared plus 45x cubed 420x cubed plus 945x to the fourth plus 945x to the fifth. Our reverse Bessel will be 945 plus 945x plus 420x squared plus 105x cubed plus 15x to the fourth plus 105 plus 1x. So 945 plus 945x plus 420x squared plus 105x cubed plus 15x to the fourth plus x to the fifth. This completes the use of the Google Sheet and Excel functions uh, to generate the Taylor series expansion of Bessel and reverse Bessel polynomials.